Dr. K. Elder has sent a message on chat. Bala from Singapore has also joined us.
Good afternoon, everyone. We are just waiting for 5 minutes to allow people to join in. So just bear with us for another 5 minutes.
Yeah, that's right.
I think we'll start now. Dr. Alan and Dr. Priya. Great. So, good afternoon, everyone, and welcome to the first session of Meet the Guru series, a joint initiative of Cooper Surgical and Life in Vitro Academy. Meet the Guru series is actually more about learning, having more insights and learning from the lives of pioneers in the field of ART. And who better than Dr. Alan Trouson himself to be the first guru in the series of Meet the Guru that we are starting. So, although he doesn't really need an introduction, but let me just give a small brief about him. Dr. Alan Trouson is the Emeritus Professor for Monash University and a distinguished scientist at the Hudson Institute of Medical Research in Australia. He is the former president of the Californian Institute of Regenerative Medicine. He has been a pioneer in the field of human in vitro fertilization and has introduced 2 world first procedures which greatly improved the success rate of in vitro fertilization. They were the use of the fertility drugs to induce multiple ova and the freezing of embryos for future use. He was appointed the director of the Center for Early Human Development at Monash University in 1986 and deputy director and director of the Monash Institute of Reproduction and Development from 1990 to 2003. He's led the Australian team for the discovery of human embryonic stem cells. Thank you. In the late 1990s and was awarded the first Australian Biotechnology of Excellence Award. He's also the founding CEO of the Australian Stem Cell Center. He founded the Monash Immunology and the Stem Cell Laboratories at Monash University. His major areas of interest include cloning, stem cells, biotechnology, cloning for agriculture industry, gene storage, and IVF. And in conversation with Dr. Alan, we have our very own Dr. Priya Kannan. Can we have the next slide, please? Dr. Priya Kannan, as we all know, after finishing her MBBS in India, has been trained in reproductive health and human genetics from the University of Sydney in Australia. She has also got the master's degree in clinical embryology from the reputed Monash University in Australia. She's been practicing in the specialized field of infertility and genetics since 2003. She is a qualified clinical embryologist. Her expertise in the field of embryology is very well known, and she is on the advisory board of many IVF clinics across the country. Apart from infertility and genetics, her special interests are adolescent health, PCOS, and hysterectomy, options for many gynecological conditions. She is also the assistant professor in the medical genetics in the Tamil Nadu MGR Medical University and conducts free genetic clinic in government RSRM hospital on a weekly basis. She is an active member of the Academy of Clinical Embryologists of India and was the immediate past president of ACE India. She's also an avid teacher. We all know that. We've seen her in various forums. And her passion for teaching embryology is evident by the association that she has with many courses across the country. So, Dr. Priya, I leave it now to you for the conversation with Dr. Alan.
Hello, Alan. How are you?
Very well, Priya, and thank you very much, Shipra and Alex, for inviting me to come on this program. I think I'm the first, so I hope it goes well for us.
I must say that all that introduction probably that was given to me was after I did the course from the course you started and the course at Monash. So thanks to you that me and many of us have done the course at Monash now in India, and some of us have come back and some of us are there and all over the world and everything. Thanks to you for that.
There's a very popular course, and I thought it was something very special, and I was so glad to get it started. And there wasn't so many people in the beginning, but we got more and more people, and I think it worked better and better. And we eventually turned it into a pretty good program for a master's clinical embryology, and I think it's been very useful. So I'm pleased to see that you're one of the graduates from there, and I'm very happy to see you in all your roles.
Thank you. Thank you so much. So we would love to get to know you, and that's the whole point of this program. So let's start from the beginning. Can you tell us something about your early childhood days?
And I grew up in the country in Australia. I had my parents, my father worked for an oil company, and after the Second World War was out in the country. So I gravitated to be interested in animals and farming, and I asked actually to go to an agricultural high school, a boarding school. So to leave home and go at 11 years old, go to just outside Sydney to an agricultural high school where I was able to work with animals. We had sheep and we had cattle and horses and poultry and pigs and everything. And it was a very, very nice 5 years of high school. So, my early days were really around the family, but very much an interest in animals and animal breeding and agriculture.
Yeah, that's, I guess, was the base. How did the move from animal research to human IVF research happen? Did the experience in animal research shape your thought process when you shifted to human research?
No, very much so. So, those in those early days, um, I was when I went from high school to university. I wanted to be a veterinarian, but I was offered scholarships to do wool technology, and wool and sheep were the really major products of Australia was selling overseas. So sheep and wool were very important, and so I did wool technology, but I focused on genetics and physiology, and eventually got a degree in basically in agriculture, but with an emphasis on the sheep and the wool. And then I did, at the time I did a master's degree in genetics, but then I went on to work with Neil Moore at Jerilderie. And those days were wonderful days. Jerilderie is a long way from Sydney. It's out in Western New South Wales. We're on a huge property, 100,000 acres, and we had 60,000 sheep to work with, just the two of us. So we had this incredible resource for doing basic embryology in a sheep. So I was really learning at that time, and these are pictures of Jerilderie showing up here. I learned to collect eggs and sperm and to fertilize sheep eggs and grow embryos in the sheep. It was all part of my PhD, and so that was an incredibly good grounding, if you like, in basic embryology. And the opportunity came up when I finished my PhD to go to Cambridge, which was, in many ways, we all talked about Cambridge being the mecca for embryology. That's where all of the primary animal embryologists all went to sort of become major embryologists going to Cambridge. And I was at the Agricultural Research Station just out of Cambridge, and I had 3 wonderful years there in research. And again, it was all focused on fertilization in sheep and cows and pigs and rabbits and horses, and it was all about the understanding the egg and then using this, collecting the sperm and treating the sperm in order to get fertilization in vitro, and growing out the embryos and understanding, what a viable embryo was. So that was a pretty perfect sort of background, if you like, for IVF. And at Cambridge at the time, Bob Edwards was there. I knew Bob Edwards quite well. We didn't talk a lot about human IVF, but we talked a lot about animal embryology. And when he knew I was going back to Melbourne to join Carl Wood in Melbourne to help him develop a human IVF, he was very supportive, and he said he didn't offer to help me, but he was very encouraging about having someone like myself with the kind of background that I had, which in some ways was similar to his, as a person who would come into a clinical department where there wasn't that kind of expertise present in Melbourne. So I took up the job in Melbourne. I came back from Cambridge and went to Melbourne. And Carl Wood had started IVF back in 1970, really at the suggestion of my supervisor for my PhD, who was Neil Moore, the guy who I worked with in Jerilderie, had suggested IVF because Carl was trying to make artificial tubes to replace women's blocked fallopian tubes, and that really wasn't working. And Neil suggested that he do IVF, and he began that in 1970. He asked me to join them before I went to Cambridge, but I decided I really wanted to go to the sort of top place in the world and learn from all the masters rather than go to human IVF at that time. But when I came back in 1977, they'd had a long time trying to get the technique to work. They would use fertility drugs. They'd try to repeat the kind of things that had been done elsewhere, but they really hadn't had any success. They had what was a very short pregnancy, I think in 1973, only maybe a week and they did detect HCG in the patient, but nothing more. And so when I joined them in 1977, there really wasn't room enough for me to help in the IVF in the beginning, but Carl Wood asked me to sort of really join in 1978, 79, and I asked really if I could do the IVF in the way that I was trained to do IVF in animals. And so instead of following along in the footpath of Bob Edwards and Patrick Steptoe, I decided that I wanted to do it the way that I knew worked in animals, and I figured the human wasn't that different to animals, and while there are some differences clearly, these are not major differences when you get right down to the major biology of fertilization, eggs and sperm and fertilization. So that was an interesting move from coming from animals to the human, but it was Carl Wood who has allowed me to practice what I'd already learned rather than trying to repeat something that someone else had done. Because Bob Edwards, he'd been successful in getting the first pregnancy, or the first 2 or 3 pregnancies, using natural cycle IVF, where you collected the single egg from the woman each day of her menstrual cycle and then tried to fertilize and develop embryos there. But that method was clearly not one which could be easily applied, and it was a real problem for us to try and do that kind of work in Melbourne, because it never fitted in with any of the programs in the hospital. So what I'm saying is that I translated, what I was doing was really translating what I had learnt in animals into the human. So I'd learned how to do this kind of work in animals, and I felt that if I took the same route and I'd sort of approached it in the same way and then made modifications to optimize it, it would work. And that's exactly what happened.
I guess we still use that. I guess that was a breakthrough for us to continue doing that as well. But I must say, you in the course as well, you make us practice everything on the animal eggs, that is the mice eggs, and then we extrapolate that to learn our techniques, and then we now extrapolate that in the human IVF now. So I guess that's a model that has been consistent. When you were talking about the egg pickups in the earlier days, it used to be done through the laparoscopic way.
Yes.
And you joined the Monash group in 1978, and that is where you introduced the ovarian stimulation and sperm injection methods. Can you just tell something about the discoveries of these?
Well, I think the laparoscopy was a particularly new technique to the clinicians. Really, so they developed laparoscopy, but you know, when you're actually entering the pelvic cavity from the position where the patient is lying front up on the table, you've got quite a distance to go, and you have to sort of pass through a lot of tissues, often which are adhered, and you find, as you say, I think frozen pelvises and so forth. It can be very difficult to find the ovary and to actually and identify where the follicle is. And it wasn't until we introduced ultrasound into IVF that it started to become much better. The ultrasound was initially all done again from the outside on the patient's tummy, so there was some distance away from the ovary. But eventually, particularly the Scandinavians introduced vaginal ultrasound, and that brought the ultrasound so much closer to the ovary. And of course, when you're able to then use a needle and a needle guide, you could puncture the follicles with direct sight, rather than trying to sort of guess. Often when you're doing laparoscopy, you had to guess where the follicles were, because the ovaries weren't always really visible in the way that you would imagine. So it made a really big difference. And I remember the Scandinavians who came, particularly Susan Lenz, who came to visit us and trained us with us on this. She was from Copenhagen. It was just wonderful to see how relatively easy it was to actually approach the ovary, you know, through the vagina. And I hadn't really thought about it before, but of course, you know, in animals, sometimes you go that route when you're wanting to collect eggs in some species like the horse. So, you know, maybe I should have thought about it before, but the Scandinavians were particularly good at it, and we really quickly changed from doing ultrasound through the pelvic cavity, approaching from the patient from her pelvic cavity into the vagina, and then bringing everything much closer. And of course, success rates of collecting eggs improved dramatically. And so, you know, that was a big step forward. And when we were using fertility drugs, of course, I brought fertility drugs in because that was what was required if you really wanted to make this technique work properly. And I brought Clomid in as a very sort of a mild stimulant in the beginning, but then we added human menopausal gonadotrophin to Clomid, and then we eventually moved off into HMG or FSH products. But the early days with Clomid enabled us, first of all, to multiply the follicles present in the ovary. It gives you a much better chance of collecting eggs, and then a much better chance of forming embryos for the patient. So it all made sense, of course, but the developments were both embryological, but they're also clinical. So there was a combination of working together with clinicians, particularly people like John Leeton and Carl Wood, who were really willing to sort of, you know, try things differently, and that made a huge difference, and that's why I think we were so successful. But once we had multiple eggs, of course, we had to find solutions for those problems that occurred after that. Yeah.
Is there any particular thing that made you think of using the ovarian stimulation with Clomid or the injections? Is there any, like, a story behind it, or anything that sparked you?
I mean, in animals, we were using pregnant mares' serum gonadotrophin, which is an FSH like product that's got FSH and LH in it. But and I had used pituitary gland products as well, which were basically extracts of FSH. But I thought I wanted to stimulate the ovaries because I wanted to be able to control it. And the only way you can actually get control of the ovulatory cycle is if you actually are able to stimulate the growth of the follicles and then give a timing of luteinizing hormone to complete the maturation of the oocyte so that you knew exactly when you had to go into the patient. So setting up both for the timing of collecting the oocyte and more follicles so that you had a better chance of collecting oocytes would improve your outcomes because you're more likely to develop a viable embryo just because you had more oocytes and there was more chances, particularly in these early days when we're still optimizing the procedures. You really had to have multiple oocytes in order to get the patients pregnant. Not that you had to transfer multiple embryos, but you needed multiple oocytes so that you could grow viable embryos. And so, I was driven really by the model that I knew worked so well in animals, and it worked right across all mice, rabbits, sheep, horses, the whole lot. So I knew essentially that's what you needed to do, and it worked. Of course, it worked with a human. The differences were really more about how you treated the oocyte when you first got it. In the early days, we were collecting them in a rather immature state, and so we had to have some period of time while we finished off their maturation. So we delayed the insemination for the oocyte to catch up. And of course, everything in animals said that you can't put a 2-cell or a 4-cell or 8-cell embryo in a uterus and get it to survive, but it did in the human. And I was encouraged really by what Bob Edwards had done, and I thought maybe it's better to get it into the uterus in the first place until we optimized our culture systems. I think we probably would have been all right even in the early days, but I decided to put the embryos back into patients as soon as possible. So they were going in essentially at the 8-cell stage, and it wasn't until later that we were comfortable with the culture systems and then went on to just transplanting blastocysts. Yeah.
So with all these, we had now moved on at that point of time to ultrasound, and then we had the ovarian stimulation. We right now can't even think of laparoscopic egg pickups. Like, we are so used to only the vaginal ultrasound egg pickups. We have read that the laparoscopic egg pickup, the chance of recovery of a oocyte was around 50%. Yeah, and I mean, it's something that's unheard of right now. So I guess it must have been pretty difficult times. In that, you joined Monash in 1978 yourself with Dr. Carlwood. The team was very successful, and you produced a third IVF baby in 1980. Can you please enlighten us about those memorable days which led to the success of this birth of the third IVF baby?
Well, the third IVF baby was actually conceived at the Royal Women's Hospital with Ian Johnson's team. The team was working together, but they were working in 2 hospitals, and at that time they were working on the natural cycle IVF, and so they had the third baby was a natural cycle baby that was conceived that way. And so Alex Lapata, who was the embryologist, was at the Royal Women's, and I was at the Queen Victoria Hospital. So it was he and the group with Ian Johnson. Even though we were one group, they were the ones that were able to get the natural cycle working. I was working on on some natural cycles because we were trying to do the same thing at the Queen Victoria Hospital, but I'd asked if I could separately use fertility drugs because I didn't believe that the natural cycle was the way to go. So it was in the natural cycle. While we had natural cycle embryos, we never really had a pregnancy from any of them. And when we started to produce lots of embryos from the clomid stimulated patients, we suddenly had 14 pregnancies in a row, basically. So a really large number of them, and that had not occurred anywhere in the world. And we could do this, timing it so that we could actually pre-program the theatre in the hospital, and we could tell the patients when to come and what to do, and when the husbands be there. It made everything so much simpler. So that was incredibly successful, and I remember going to a major reproductive meeting in Berlin in 1982, and nobody had really seen this data, and I was giving a talk on it, and it was there must have been 1,000 people in the meeting, and I kind of, as usual, got a bit over time, and the chairman wanted me to sit down, but the whole of the meeting shouted at him to let me continue to the end, and it was quite an extraordinary thing, because suddenly the world realized that there was a different way of doing it, and a very successful way of doing IVF. And that, of course, really was a major turning point for the whole of the technique. Everybody then sort of moved into that kind of technology. So we were training all the people from France, from the UK, from Belgium, and from the US and Canada and everywhere, because they all wanted to learn, these sort of basic technologies, because they had all been programmed to sort of try to work it on natural cycles, because that's what Bob Edwards and Patrick Steptoe had been successful with. Yeah. So, so it was exciting. First, the third baby was exciting for Australia, but to me, it was so much more important to be able to get the technique to work very effectively, in my mind, and reproducibly, and in a program way. And suddenly the whole team knew exactly what they had to do every day, instead of having a team which didn't know what they were doing from day to day, because you couldn't predict what was going to happen in a natural cycle. So it made a massive difference, and it really changed the whole of the IVF, I think. Just bringing in that, and so that was incredibly exciting. Everybody was profoundly excited, really, that it all worked. So was I, of course, but it was a whole team effort. Clinicians and nurses. We had key nurses like Julian Wood who were with us, and key embryologists who were doing work that were backing me up in those days, and it was fantastic. It was a really big buzz of success. Yeah.
Oh, that's so nice. I mean, I guess when we read about how Dr. Edwards and Steptoe used to do the program, that they had to, they would program the OPUs in the middle of the night and everything. We always are awed at how would you actually do that? Because right now, IVF is such a well-oiled machine. It goes like you give the HCG and then take the trigger, or loop right and take the trigger. And I guess the introduction that you made, I think, was the start of how now we go as a well-oiled machinery. Like we don't even think about it. Like we don't even have any problems about, okay, today you give the trigger, the day after morning you just start the pickup, and that's as simple as that now. We can only imagine how difficult it was to do the natural cycle. But I guess along with the introduction of ovarian stimulation came the concept of having supernumerary embryos. I think you gave a solution for that as well. So
That's
the
right.
first 1,000 embryo pregnancy by you was achieved in 1983. You have attributed the success to the meticulous care as well as the change in embryo freezing timing. And you started freezing between 4 and 8 cells. So you had the slow freezing, I guess. So, and what made you employ? I mean, how did you think of the changes, and how did you, what method you used, and how did you come to that, as you say, to reproducibility and to know exactly what was happening in that side as well?
But to go back again to Cambridge, where we were developing embryo freezing for sheep and cattle, and while I was there, we were successful in developing those methods, and so I was working with Steen Willardson there, and that was fantastic. So really, people hadn't been able to freeze embryos of sheep and cattle, and clearly there was a big call for freezing cattle because they wanted to move animals around as embryos and sell them as embryos, and have the industry take over as embryos rather than live animals. So there was a big demand, and we actually got it working. And I kind of remember Mr. Rosen, who was the head of the Cambridge group that I worked with, and he brought some cow embryos for Steen and I to work on, and he used to smoke a cigarette, and I just watched the ash off his cigarette fall into the dish of embryos, and I just grabbed the embryos as quickly as I could and transferred them into fresh medium, and those were the embryos that worked for us in the freezing system. So we developed a very good freezing system, and it was based on slow cooling, using a slow cooling machine from Planer. So we kind of, played around with this machine. We drilled holes in it and made all sorts of different things in it so it worked for us. But we had a freezing system there that worked really well, and so embryo freezing in these species was working really well as a result of the research that we'd done at Cambridge. So I thought, well, why don't we start with that method? And I used dimethyl sulfoxide and the same sort of balanced salt solutions, Dolbeco's salt solution and so on, the same as I use for sheep and cattle. And I tried that out and it worked. So when I sort of saw these human embryos coming back looking beautiful, looking really terrific, I think, this works. This does actually work. And other people, refined the freezing system using propanediol and other solutions. But those initial studies with dimethyl sulfoxide worked really well, and they were just exactly what we were doing. We developed for the sheep and cows. So you see, it translated again from the animal studies that we'd been doing. I think I was always interested in figuring out how to vitrify solutions, and that I spent a lot of time with the people in my lab working on rapid freezing systems and vitrification. We eventually got that to work, and of course that's even better than freezing now. So that was a really interesting sets of experiments. But the original work came from animals, and then when I was still working with the human, we were developing vitrification solutions and rapid freezing and ultra rapid freezing, and then eventually got it all to work and produced the first babies from vitrification. So it was interesting times, a natural evolution again from all the animal work that I'd done. Yeah.
Yes, that's amazing, because you gave us having how to make supernumerary embryos. You also gave us what to do with the supernumerary embryos. I guess that's amazing. So, but we have take a liking to your vitrification that you're taking, because I guess now we don't do any of the slow freezing. I guess except for one or two, we don't do slow freezing. So I'm like, we are terrified of slow freezing now. We just love the vitrification alone. So that's how we have become now. So, and I remember when I was in Australia, there was always this, way back as well, there was always this dedication towards QC, QA, and reporting of all the procedures we did. I guess Australia was the first country to report on the birth outcomes of IVF and GIFT procedures since 1980. And the success rate was comparable in all the 7 IVF centers in Australia then. And how was the scenario in the early days?
Well, I think the GIFT procedure was being used for patients with idiopathic infertility, where at least the patients had a patent fallopian tube. So I think it was a relatively straightforward procedure. You could load sperm and eggs into a catheter, and you put them, using laparoscopy, you would put them into the fallopian tubes. I think as we sort of moved on with IVF, as it got better and better and better, GIF wasn't really necessary, and because we didn't want to do laparoscopy anymore, it fell by the wayside. But in the beginning, all the teams were pretty much the same, and I think we were introduced to it by Ricardo Ash, who came to work with Ian Johnson, and all the clinicians wanted to do it. That's true, but you know, I found it a bit less interesting because it seemed to be, you know, I thought there was many more opportunities to improve systems if you had the eggs and sperm in vitro, and you could go then and do genetic analysis of it. You could actually look to see whether the embryos were carrying genetic diseases for some patients who've got inherited genetic disease, but you could also possibly look for chromosomal abnormalities in some of these embryos and so on. So, you know, with GIFT, you wouldn't be able to do that. And so I was interested in pre-implantation genetic diagnosis. They wouldn't let us do that work in Melbourne. And Leander Wilton, who was working with me doing that, she went off to London to work with Alan Handyside. And she went to the zoo there, but she worked with Alan Handyside in London, and they got that the pre-implantation genetic diagnosis working really well there. So later on, we were able to introduce it back, but because of we weren't allowed to do embryo research in Victoria because the government had decided that we were going too quickly. And they had a committee there that wouldn't let us do experiments unless we got it passed by them. And they didn't really want anything to do with pre-implantation genetic diagnosis, which was a pity, really. So, but that was the reason why I was more interested in IVF than in GIFT. And eventually GIFT died out, really, because IVF is simpler and is more successful, I think, than GIFT. And of course, you can use it for all patients, not only just idiopathic infertility patients.
We don't seem to use GIFT anymore right now. As you said, it's died away, and we just stick only to IVF now. It's, as you say, it gives more information about what we are doing. I remember when I was there in Sydney, in University of Sydney, we always knew that Victoria was more stricter on the IVF side than in NSW. So actually, I started my project with Professor Jensen on social sex selection of embryos. And then as following Victoria, New South Wales also banned all of the social sex selection right in between a project. So I had to close it and start another new one. So I guess one by one, everybody started having their own regulations and everything. And a lot seemed to have happened around 1980s in Australia in terms of IVF and regulation as well. The first institutional ethics committee for IVF was also convened in Queen Victoria Hospital around 1980, and the FSA was established in 1982 under the chairmanship of Dr. Johnston. How was the response of the general population and the regulatory authorities of Australia towards IVF in those days?
I think the general population was always very supportive of what we were doing. whenever they did a poll, and they did a number of them, we always had more than 70% of the population supporting us, which is pretty good, really. And there were people who were negative, of course, but they probably already there probably is even some now who are don't support it, but in those early days, the church was kind of very much against it, and the radical feminists were against it because they thought it was men manipulating women's bodies. Essentially, that was their argument. So it was a strange combination of religion and feminism that was against it. But it was a strange time because we were making these breakthroughs with freezing and egg donation and sperm injection. All these kind of things were happening in Melbourne, and so there were breakthroughs happening really all the time. And so the community was sort of highly revved up on this and generally very supportive. So there's a magazine showing you there. There's a sort of picture of me sort of taking over God's role, and really, and in some respects, it was a sort of totally wrong type of thought about it. So instead of what we were trying to do was really solve problems for infertile patients or patients who had inheritable genetic disease, it looked more like, we were trying to make ourselves more important and maybe take over the role of God, and that was kind of strange. So sometimes we were lauded, and sometimes we were heavily criticised, and I think some of us received a lot of death threats and so on. So it was a difficult time for our families because there was a lot of arguments in the community, but we felt, and I felt, we were doing the right thing, and eventually, as more and more patients had children from IVF, it became, it started to settle down, and eventually, even the response of governments, to slow us down and to stop us doing what we were doing in terms of research, they sort of switched off into more regulation. So it was important the Fertility Society was created, and it was essentially created out of the artificial insemination interests that were happening before we got IVF working. But when IVF came along, it gave a bigger impetus for a professional society to show that it could regulate and make sure that clinics were doing the right kind of thing and that they weren't doing the wrong kind of thing. And so the Fertility Society created a special audit group that audited all the clinics and made sure that their procedures and the people that were trained properly, and they were doing the right thing by patients, giving them, the right information and helping them through the procedures and so on. So that was very important, and it has survived until today, really, as an audit system and an own audit system, and I think it was particularly good. I think there's a picture there of me and my daughter Kylie, who my daughter wrote a play about. She called it The Waiting Room, about the beginnings of IVF, and that were her memories as a very small child, because she was born in 77 when we came back to Australia, and she was very young in those 80s, where I was working in the lab, and I used to bring them into the lab with me at times when I was working on the weekends and so on. And so she got a sort of picture of what was happening and what the clinicians like Carl Wood were like and so forth. And she wrote a very interesting play that went for a whole season, and it was it was full up every time that she had the play was played through the whole season. And so it was thought to be a very successful play, The Waiting Room. But it indicated that there was a lot of interest, by the community in the whole issue of reproduction and opening up reproduction from something that was pretty secretive into something that people could start to understand. Why am I getting pregnant, or why am I not getting pregnant? And I think it's really been a very helpful revolution of information, and I think plays like Kylie's sort of make it much more humane. And while she wrote it from her point of view and not mine, I quite often didn't even recognise the players, but they were particularly what she remembered from those times, and it was very, very interesting. So there was a sort of melting pot of interests, and there was a lot of. I eventually had to persuade the federal government to be supportive of IVF, and they were. They had to have votes on IVF, and then later on they had to have votes on embryonic stem cells as well. But those votes and those debates were pretty ferocious, really, because it wasn't on party lines, and so there was some very strong negatives and some very strong positives there. And I spent a lot of time, in those debates trying to help people understand what was going on. Basically because the patients really didn't want to make those arguments. They felt this was their private business. Their infertility was their private problem. So we had to do that. So people like Wood and myself and Johnson and others, carried those debates.
It is very sad that even now there are lots of misconceptions about what we do in IVF. Like after decades of being there and helping patients, we still see a lot of shows on the TV and stuff saying all sorts of things that we do. But as a tangent of what you were saying, we saw that picture of yours on the magazine, the man playing God. So I guess now we have the CRISPR happening. What do you think of that? Do you think we would have a magazine like that, or?
Well, I don't think CRISPR should be used for human embryos. It's not really. It hasn't really developed in a way which I think is safe enough for using in human embryos. But we use CRISPR for work on stem cells to make killer cells for cancer. So CRISPR and the gene editing tools are going to be marvelous tools for us to use, but I think it needs to be used very carefully. And there's work in China where a Chinese scientist used CRISPR to produce some babies. He wanted to knock out the CCR5 gene so that the babies really wouldn't be able to get HIV. But he couldn't really be sure, at the moment, he couldn't really be sure that you might have off-target effects that could, have very unpredictable impacts. So I think it's more of a safety issue for me at the moment. When we can kind of guarantee the safety, then I think it's going to be a very, very important tool from human medicine. Whether it's used in human embryos, I will be unsure, but the research will tell us whether it could be or shouldn't be. But right now, I wouldn't use it in embryos because if you make a mistake, you can't reverse it. So it's a problem.
Yeah, safety is always the key, the priority at all points of time, I guess. Your lab in Monash switched focus back to animal reproduction, which was your where you came from. One of the pet projects you had was IVF in endangered black rhino. You even got charged by one of them. Did you face any opposition? How was experience with doing IVF in such rare species?
Well, I think I think this is a very important application back to our animals, if it's at all possible. It's a very difficult thing to do in rhinos. Clearly, they're a very large species, and while it's possible to do it in cattle and horses and other animals, it is now possible to do it in rhinos, and I think there's pictures of rhino embryos and sperm and eggs and sperm that can produce embryos now. We never produced an offspring as yet, and we have almost lost the northern white rhino, because there are only two females left. The one male that was left died recently. But we do have sperm from that animal, and we hope maybe that with eggs from either the two remaining northern rhinos or using the southern white rhino, that we may be able to recover that species. But it seems like it's a pretty difficult task, because rhinos themselves are, are poached and really challenged, really very hard for them to survive. There is a project going on at the moment to bring rhinos into Australia, where they will be free from poaching, and maybe they can breed and get up into a large enough numbers that we can take them back to Africa sometime when it's safer. But currently, we lose more rhinos there than they can make breeding them naturally, and so while I think it's a great project to do, and it would be really important, I think, to recover this species, and I think with the black rhino, the work we did in the zoo in New South Wales, out at Western Plains Zoo, with the black rhino there, was really interesting, and we were able to inseminate those animals and get them pregnant and so forth, and produce baby rhinos from those animals. So that was really interesting, and I've had a long history, if you like, of sort of wanting to continue to help with endangered or animal conservation. And I'm part of an African breeding institute for rare and endangered species, where we have students who are doing a lot of work on pygmy hippos and the red Ethiopian wolves and all sorts of species, including the rhino. So I think what we learned from human IVF, if we could sort of take it back to help some of our other animal species, it would be wonderful. But it's not a very easy thing to do, and there's not a lot of money to do it. That's a sort of huge problem. And so it's a tough business to do, but I remain optimistic that, that we all should want to keep as much biodiversity as possible.
Absolutely. Here there are labs around in India as well, like the vet colleges who do IVF for animals, even lions and tigers. And as a joke, I always keep telling my son, like, once I'm like done, I'm going to move on to animal conservation. You can find me only in the Vandalur Zoo, which is like a huge zoo here in Chennai. So I tell them, maybe I'll shift my house there and I can live and you can come over and visit me. I think it's a major thing that we should be able to use the technology that we know to conserve animal species.
Right.
And another breakthrough that you had, a huge one, I guess, is the isolation of the human embryonic stem cells in 1988, shortly after the group which did in University of Wisconsin. How was the change from human IVF to stem cell research?
Well, we got interested in making human embryonic stem cells, basically because the mouse embryonic stem cells were such a powerful experimental tool for functional genomics, and as it turned out, for differentiation into all sorts of tissues. They were mostly using mice for functional genomics, but I had a strong interest in seeing if we could differentiate those cells, if we could make them in the human into different tissue types, and it might lead us to the origins of some birth defects and early childhood cancers. That was my main interest at the time, and Arif Bongso from Singapore was a close colleague of mine, and we'd worked together off and on, and he'd spent a sabbatical with me in Melbourne. And I went back to Singapore and spent a sabbatical for 1.5 years with Arif at the National University of Singapore. And the Singapore government gave us approval for making human embryonic stem cells. We couldn't do that in Melbourne because of the committees wouldn't let us experiment in that way. But the Singapore government gave us approval through their ethics committee. So we were able to do that. I think we had the embryonic stem cells much earlier than both Arif and I realized, because they were different to the mouse, and we were looking for something that's exactly like the mouse, but it is a little different than the mouse embryonic stem cells. But as it turned out, we had them in the laboratory and had them down in Melbourne in the laboratory growing when we received Jamie Thompson's paper describing how to make human embryonic stem cells. So we had them there. We just really hadn't characterized them fully. So we endorsed his paper and went on to show that you could drive these cells into neurons, the neural lineages and so on. And it was a really big development. And it led to embryonic stem cell revolution, really. The Australian government ended up awarding me a Biotechnology Centre for Excellence for that work, and provided me with an enormous grant at the time. It was 54 million, and the Prime Minister doubled it to 110 million to get people in Australia to work together on the development of the embryonic stem cells to see if we could sort of turn them into benefit for human medicine. It was probably a bit early because it didn't work out quite so well in Australia, but what happened was Bob Klein, who was in California, he'd run a bond raising program for raising $3 billion of Californian funds for embryonic stem cell research in 2003, 2002, and on the basis of human embryonic stem cells. And he got the Californian voting population to endorse that during their they put those propositions to the community at the same time as they have elections. So it's the same time as they elected Arnold Schwarzenegger governor of California, and that got more votes for the stem cells than Arnold got for being governor. So that was something quite special. But they asked me to go and head that up in California, and that really turned into a huge revolution to have that amount of money to drive that. So yes, it was a very big development, and the people of Arif Bongso and Martin Perrer and Ben Rubinoff from Israel, who all working with me to do that, they did a fantastic job in getting that all to happen, and I think we're all very pleased that it worked out, because those embryonic stem cells really are dramatic, and from there we were able to the people in Japan under Shinya Yamanaka were able to figure out how to make induced pluripotential stem cells, which are almost the same as embryonic stem cells, using the transcription factors that embryonic stem cells use. So if you hadn't discovered the embryonic stem cells, you wouldn't have been able to discover the induced pluripotential stem cells. So it was a huge development and a massive breakthrough. So we were very happy that we were part of that, and I had a great team again working with me to do it.
So the first grant that you had was the missile. Is the result of that? Was the result of that?
What was that?
The missile, MISL, that is the first one, and then That is the one you set up in Monash.
Yeah, no, that's
Yeah.
right. I left the National Stem Cell Centre because I still wanted to do the research. I'm mostly interested in the research. So went back to Monash and joined up with Richard Boyd, who's an immunologist. So we created the Monash Immunology and Stem Cell Labs there. And we had about 200 scientists working with us to sort of, make embryonic stem cells into something that were useful for medicine. We're doing the really basic research, which really needed to be done before you turned it into a human medicine. So that was great. That was a fantastic time with that group of people. And that, in 2007, they offered me the job to go and head up the Californian Institute of Regenerative Medicine. And so when Arnold Schwarzenegger came on the telephone, and I thought it was a friend, one of my friends having fun with me, but it was Arnold, and he offered me the job, and he said he would really like me to come and head that up, and it was 7 years of fantastic work in California. Really was wonderful.
You were the president of the California Institute of Regenerative Medicine.
Yeah.
And so you shifted there. So how was the move between Australia to California?
Well, it's different. California is different to anywhere. It's a can-do place in the world. If you can do anything in California, you can do anything. And with $3 billion, you can start a revolution, I can tell you. So I was able to back some wonderful research and also some translational work to get stem cells moving into the clinic in blindness, in diabetes, in all sorts of things. And by the time I left, I think we had about 30 clinical trials running, and I think now there's about 80 clinical trials running in that program. And so there's so many possibilities for treating patients as a result of all of that. I think it is just a massive change in the way we do medicine. So cell therapies and really discovering drugs based on having those pluripotent stem cells, whether they're embryonic stem cells or iPS cells, induced pluripotential stem cells. They grow forever. They're immortal, and they can develop into any tissue you like. So you can imagine that the possibilities are just enormous, and I think they
Absolutely.
will be, a very major medical advance for regenerative medicine, and it appears to be the case. So in the first place, a lot of the developments went to cancer. Some very successful cancer companies spun out of all of that because we were studying not only the stem cell, but the cancer stem cell, because that's an important one as well. But Parkinson's disease, a lot of the neurodegenerative disorders, all could be treated with stem cell derivatives, and it's just fantastic, the opportunity. It really is.
And Arnold Schwarzenegger, the former governor, was of great support to the stem cell research. Can you hear me? Am I audible?
Dr. Alan, you are on mute.
Okay.
Everyone right?
Yes. No, she is. Alan Schwarzenegger was one of the supporter of the stem cell research in California.
Sorry, I didn't hear all of that.
Arnold Schwarzenegger was of support to your research in California.
Arnold Schwarzenegger?
Yeah.
Oh, right. Yeah. No, he was. There's a photograph, I think, of Arnold in the deck there. He's a marvelous man. Bob Klein is the one under the flag with the star on it, the Canadian flag there. Arnold was governor in California, and he was very, very interested in this area, which was that was quite different to President Bush, who was quite disinterested in stem cells, and that's why the CERM was established, because President Bush wasn't supportive. But Arnold was a Republican, but he was very supportive of this, and but he had a bad knee, and he also had some heart issues. So any of those subjects, he would sort of really become alive and want to know what was going on with those kind of things. But he really felt that there was a great opportunity, and was very supportive of all of the people who were working on it in California. And for the whole of his governorship, he was really very special to come and talk to. And sometimes he would, because he's an actor, he'll remember exactly what you told him, and you could actually hear your words coming back to you sometimes. So his memory was very, very good, and he knew exactly who you were and what you were doing, and so on. So, a very special man. I enjoyed his company a lot.
Oh, that's really nice. I mean, those are the insights we don't know about Arnold at all. So that's very nice.
Yeah.
We thought it was all like, he was the governor and so far from here, and all we know is his body and is like brawn, all brawn, and we didn't know the soft side of Arnold at all. So that's nice.
Yeah.
And to say something about your leadership, Jeff Sheehy has told one of the key features of your extraordinary leadership was the seamless integration of patients, industry, researchers into a harmonious synergistic union. Would you like to say something about that?
Yeah, I think the what was really important here was we're not only backing basic research, but what we were doing was making the discoveries translate. So we had enough money, and so what we said to the scientists who were working there, now you want to take this discovery forward. We want you to work with industry, or actually get industry consultants working with you. So to make sure that you continue the focus all the way through. So what was happening was with the development of very synergistic union between the academic researchers and the business people who were very, very good at getting these things done, and concentrated right on getting those discoveries moving right through the clinical trials and into the clinic. It was a very special opportunity, and I, many people told me that the scientists wouldn't really work with industry in that way, but they did. I mean, I said there wasn't a choice, so you got the money if you did it that way, and you got the money. But once they worked with industry, they were really, really good at doing that, and a lot of these developments are now spun out of those partnerships, and so I think it was a model that could work really very well around the world, and I've always advocated for industry to work much more closely with academia in order to get the developments into the clinic and into patients. So I think it's a special thing, and clearly people like Arnold Schwarzenegger recognized that right in the beginning, and he would say those things, as you said, and he really did mean it, and that was the way that was the way Bob Klein and Jeff Sheehy, who was a board member, they all felt that if we could do it that way, it would work, and it would work. It would produce the outcomes that we were sort of looking for. Can we cure Parkinson's disease? Can we cure type 1 diabetes? I think they're all up for it, and I think it'll show as the work continues to go that we won't have any blindness anymore, not from macular degeneration, and we won't have cartilage problems, so that'll all be corrected, and a lot of the neurodegenerative diseases will be able to be treated. So I think there's a huge amount that is going to get done really over the next decades, I think, of that kind of work. So, you know, I'm a scientist who wants to see discovery go and do something. So it was like IVF, like the animals. I wanted the breeding work to go out to the animal industries so that would change the animal industries. I want to see the research go and do something. And so that's the kind of person I am. I think that's worked very well. And in the case of CERN, when you had $3 billion and a lot of support, you could achieve a lot. And so in the 7 years I was there, I felt I achieved an enormous amount. And it was a very happy time, that time there. Yeah.
Oh, that's really nice to hear. But you're not only on the really technical side, but you're also somebody who's interested in giving the technology to as many patients as possible. And hence, you co-founded the Low Cost IVF Foundation in 2007 in Switzerland and the Friends of Low Cost IVF in USA. As a pioneer in IVF research, do you think that the escalating cost for the current IVF process is not reachable to the mass? And how do you think we can make this technology available for everyone?
I think that's an important thing. I mean, when I was at WHO, the women from Africa and Asia came to see me and they said, we deserve IVF too. It shouldn't just really be for the developed world and you know, the population of the developed world. We should have it too. Why don't you develop IVF for us? And I thought they had a good point. And what we'd been developing are becoming more and more expensive. It was more and more difficult to actually get down into African villages and Asian villages and so on. And, you know, wherever there was resource challenged populations, they weren't going to be able to access that. There's a lot of criticism from, I think, wrong criticism from people that, you know, poor people shouldn't have IVF, shouldn't be made available to them because they can't look after children. Well, they can clearly look after children very well because they often have a village mentality where everybody looks after the children, and they do that very well. And it's clearly important for particularly women to be able to have children because socially it can be a massive penalty for them in some societies if they're unable to have children, and so, you know, they can end up being badly hurt or removed from the family or, you know, lost on the street just because they can't have children, which seems terrible. So my view was, well, I know that we've been developing this high technology of IVF really, and because it's settled in the developed world, that's where people can pay for it. But why don't we try and create a more low-cost procedure that could actually work, using maybe clomiphene together with maybe a little bit of HMG and so on. Go back to some of the earlier studies that we were doing. Teach them how to do sperm injection because, you know, you probably need that along the way, and how to vitrify your embryos so that you only transfer one embryo, not, you know, 2 or 3 embryos. So we were doing that in Africa and Mexico and other places. And currently the place that's sort of working for us quite well is in Harare in Zimbabwe. No IVF there. They had a lot of young people who really wanted it and had nowhere to go except to South Africa, for which they cost them a lot. You know, they basically couldn't afford it. So we set them up. We helped them set up. And this has been good because both the clinician and the embryologist were both infertile, and they both have had children as a result of the work in the clinic now. But they're committed to it unfortunately, in some of the other clinics we set up, once we trained the embryologists, they went off to the UK or somewhere else because they came highly trained. And so why wouldn't they? They got a good job somewhere else. So you couldn't blame them. But it, you know, it was hard to keep it intact at a low cost because it wasn't making a lot of money for everybody, but it was making the technique, maybe making IVF available for the people. So this one is working really well, and we want to continue to do that. We use lots of simplified systems, and you can do it for a few $100s rather than thousands of dollars. So it is different. Would it work in Australia or America? I don't know. I don't think so. Probably won't. I think people are looking for something different. They expect a high technology. They want a quick success rates and stuff. And so I'm not sure you can actually do the low-cost IVF in a developed country. I'm not sure it's suitable. But if we rethought everything around, maybe we could make it much cheaper for the most simple of IVF. You know, block tubes and everything else, but young people and so on. It could probably work quite well as a low-cost procedure in that environment. But what we're doing in Africa is really charging the patients. Really, they don't get charged more than a few $100s, and then every fifth patient gets treated free. So some of them, you know, it's every 20% of them are getting treated for no cost at all. So we thought that was something that was worthwhile, and maybe it will translate to other places, maybe not. But you know, that's the one connection I have at the moment in IVF, and I'm not trying to persuade other people to do it, but you know, if people want to do it this way and it's working really well, I think we can help them get trained. Yeah.
Well, I guess just to tell you a few things about the IVF scene in India. I guess we do have a lot of medical tourism. You might know about it. India has got a lot of medical tourism, and IVF is also part of it. We do have, because we are able to give the IVF, we do here almost at 1/3 or 1/4 the cost of that in developed countries. There's a lot of medical tourism who for IVF as well in India. So we have patients coming from all over, and we have been able to do it. We have about 2,000 clinics in India, to 2,500 clinics in India, IVF centers, and we have been able to reduce the cost to a certain limit. But I guess with more regulations and more technology being made to do, I guess there is a point at which we are not able to bring down the cost because we need to add more AHU and then more filters in that, and with COVID add some more into that. So that's being slightly difficult, but we really appreciate you looking at the cost, being one of the pioneers and a founding person for IVF, and it's important that to look into it as well, to take this technology to all women who require that, so that they also can have a child. And you said in India as well, if somebody doesn't have a child, they can be ostracized. So the family, the woman in particular, and the family in general. So I guess it is important in a lot of cultures to have a child. Even in our government, some of the government hospitals in India do offer IVF at like, probably if you like 25,000 rupees, that's probably $200 or $300, and that's about it. So the rest is paid with the taxpayer. So I guess we are something we can do, but we're still not able to take it to all the people who require this technology.
Yeah.
I wish to quote Dr. Martin Pera. Me as one of his students as well, I don't think anybody who's been under him can forget Dr. Martin Pera, Whenever we used to go into the department, even at the wee hours of the night to make our media or do whatever we need, Dr. Matipura would be in his cabin doing something, reading something, doing some research or something like that. He was just an awesome personality and we were always in awe of him. This is what he told about you. One thing's for sure. Trounson learned it a big way from his difficult experiences in Australia. How far is that true?
Look, I think I've had a very privileged life. Really, people have let me do things the way I wanted to do. So I can't complain at all. I have been criticised based by people who disagreed with me. I'm okay with people who disagree with me, but I think I'm willing to debate with them whether they're correct or not. I certainly have had challenges from politicians and from people who are high up in business and so on, and universities. It hasn't been a simple life, but I've enjoyed every minute of it. So I don't think I can complain about anything. But if you want to do things your way, it's not going to be everyone else's way. So you're going to run into disagreement. And if you're inside a university, I think on every one of the vice chancellors that I had at Monash University, every one of them I was had to report to the office to explain myself over something. But generally, all those people supported me one way or another too. So I think the politicians, some people will never forgive you for IVF or for embryonic stem cells because they just have that view that that's the way they are. They think that's not a good thing. But there's so many other people who think different to them that it's okay as well. So it's all right to have people disagree with you. You just need to make sure yourself you feel strong enough, and I always did. I felt that if we're going to do something, we should try and do it. I felt if we're going to make embryonic stem cells, it's not going to be easy. So why not go to Singapore and work with Arif Bongso and bring Martin Perrer out of Oxford and Ben Rubinoff from Israel and do it. And so we did it. People didn't like it. Some people didn't like it much, but other people thought it was fantastic. So I think, am I a better person having been through all that? Probably. Would I do it again? I would do everything again. Every single thing that I've done again. So I don't think I've actually really harmed anyone that I can think of, but I've worked with some amazing people, and so that's been fantastic. I mean, and every time I've succeeded at something, it's been working with somebody. So Carl Wood for IVF, with Martin Perrer and the others with Arif with the embryonic stem cells. Currently, it's with Richard Boyd. I've had these wonderful partnerships, Dean Willardson when I was back in Cambridge. They're just very meaningful things. So to have actually worked with geniuses many different times and to be able to get from them and to give to them and to make something that's special is itself very special. And I've lived a life where I've done things my way and it's worked out for me. Pretty much always worked out. Doesn't mean every experiment's work because it's not meant to do that. You create a hypothesis. Some of them must fail because you can't get it right all the time. But essentially, when we wanted to do something, we did it. Even if we had to bend the rules a little bit to do that. And I mean the rules that, you shouldn't have, you weren't meant to do embryonic research in Australia, so I went to Singapore to do it. So that's a bending of the rules a little bit, right? In Singapore was okay.
Force your way to get what you wanted to do, and I guess it's a boon to the science. It's science grows, whether people like it or not, whether they allow it or not. I guess science, the right science, always grows. Yeah, I guess we just have to accept, like, science. That's what I sometimes we have read that there was a huge opposition to IVF in Britain as well when Louis Brown was born. I'm sure the children of those politicians who went against it are having IVF right now, so, or acceptable to IVF right now. So new science is new philosophy. Probably next generation would accept it even better. I guess yesterday's philosophy is today's practicals. So common sense. So it goes. So going from there, now we are into developing chimeric antigen receptor technology, CAR-T, and T-cell receptor therapies using IPEX. So as an on and off shelf approach to treating cancer. How did you come up with the idea? How was the success of using these as treatment options in terms of for the cancer?
If they could show that video, it would tell you a lot.
Inside all of us lurks a serial killer. A killer whose primary function is to kill and then kill again. These are cytotoxic T cells, a specialized member of our white blood cells. They patrol our bodies, identifying and destroying virally infected and cancer cells. And they do so with remarkable precision and efficiency. There are about 5 million T cells in a teaspoon of our blood, engaged in the ferocious and unrelenting battle to keep us healthy. These amorphous blobs move around quite rapidly, pushing out their leading edge and probing their environment as they go. When a cytotoxic T cell finds a cancer cell, membrane protrusions rapidly explore the surface of the cell, checking for the telltale signs of cancer. They kill their targets using poisonous proteins visible here in red. These cytotoxic granules move down special pathways in the cell called microtubules to the interface between the T cell and the cancer cell. The T cell punctures the surface of the cancer cell and delivers its deadly cytotoxins. This is very important in our bodies, where cells are packed together, as it focuses the lethal hit on the target and minimizes collateral damage to the neighboring healthy cells.
That'll do.
The fate of the cancer cell is sealed.
So, Priya, that's these T cells are keeping us. Well, we sit here. They're keeping us safe, right? They're cleaning up any abnormal cell that's inside us, right? And if we happen to get infected, they go and remove them as well. So they're just not necessarily good enough to defeat every cancer and every infection like COVID. So we wanted to arm these T cells with ways in which they could better kill cancer or infected cells and multiply them largely. So I basically went back to my stem cell origins and said, well, why don't we find very rare donors, cord blood donors actually, who have homozygous HLA in their HLA, particularly in their major groups of HLAs. If you do that, you only need a small number of these blood samples to be compatible with 50% of the population. And that would be, in Australia, would only take about 3 of these cell lines. In India would probably take you about 10. So creating compatibility in the iPS cells and then learning how to differentiate them into killer cells and genetically engineering into them what we call chimeric antigen receptors, ways of which recognizing tumors and then allowing them to, with an antibody attached to that CAR to actually bind to the tumor and kill it, the way we're shown in that video. And we also knock out some of the inhibitors that tumors use to turn off these killer cells. So I was funding some of that in California. When I came back to Australia, there was none of this going on in Australia. So I decided, why don't we get that research happening in Australia? But I thought, if I go to the government, I'll just say, you've just been 7 years running a Californian institute. You're not a scientist anymore, you're a manager or something. So what I decided was to set up a company and to get people maybe to invest in that company. And that's what's happened. So we've had about $22 million of investment and some major government grants. And so we're building a technology, an off-the-shelf type technology based on iPS cells, gene-edited iPS cells that can recognize and kill cancer. And we're going after ovarian cancer as one of our first up cancers because it's a nasty, nasty cancer. And I think in one of the slides in the deck shows that we can very effectively kill off the cancer. I think it's shown there. I think I can't see the bottom of it. I think it's in blue where it sort of these cells will kill off a human tumors in non-skid mice. If you put human ovarian cancers into mice and then you treat them with the cells that we've grown, it can actually eradicate it. So, so building that technology really to try and take on cancer and maybe take on infections, maybe like COVID and HIV and other infections that come around. So building a technology that would do that with cell therapy, with a cell therapy. We're going into clinical trials next year, so that'll tell us how effective we're going to be. And I have about 16 scientists working with me, and Richard Boyd, my partner, and it's an exciting time. So I'm after cancer now, and if I can knock off cancer, might be time to sort of go fishing.
I'm sure you'll find some other thing to work on. First IVF, then now cancer. I'm sure you're not going to let it go. You're going to keep science growing. So now, and the company you founded is the Cartilage. So the one you founded now, yeah. But that's great. I'm sure we're all awaiting the results of your trial. Incidentally, my husband is a surgical oncologist as well, doing a lot of molecular work in cancer. So he's doing his PhD on that as well. So, and I also happen to write to Gail. She's in Cancer Australia right now, which was, yeah. So I found out Gail from some source. I think I wrote to George Lewis, and then he told me Gail is there. So I wrote to Gail, and she's in Cancer Australia. So once I was about to, we were about to have the session, I started looking around for everyone who was in the team at that point of time. So it was interesting to get to be back in touch with Gail. So now we are back in Australia as a distinguished scientist of Hudson Institute and emeritus professor in Monash University. So after cancer, do you have anything else in mind?
I think it's going to take a bit to knock off cancer. So, and so, you know, there is a twilight time, I think. I now have 4 grandchildren. So they insist on having some of my time as well. So, you know, things things
I'm sure.
Things have become a bit more demanding. But I don't know. There's always something. You know, for me, there's always something. There's always an opportunity, and that opportunity sounds like something worth doing. You know, and if it's worth doing, let's have a shot at doing that. You know, most things we've had a go of have worked. So why stop doing it? Why stop doing it?
We do love all the changes you're making in science because they seem to be having such a positive effect for the patients. So That's finally what we all aim for, to be helpful to patients. So that's great. So we would be looking forward to the cancer. And I hope, you've spent about 30 years in IVF and about 10-15 years in stem cell, now in 10 years in cancer. So that's a lot of science. So I now letting you go. I know it's very late for you, but still we have to let you go at some point of time back to your family as well. How much ever we would love to keep talking to you. So is there any principle, like one guiding principle that has kept you going and positive with all the ups and downs? What would you like to share to all of our attendees to believe in and to learn from and to keep going, to keep science going? What would you like to tell what would you like to tell the attendees of this session?
Well, I think I think we're all different. So what works for one person like me wouldn't work for somebody else. But what's worked for me is to believe. And if I believed in something, I've worked on it until I've either shown that it doesn't work, or more often shown that it does work. And so I think if you have good ideas, they're worth testing out. So believe in yourself is what I think is the most important thing. And others will come along and want to work with you. And having the opportunity to have these wonderful people come and spend time with you, work with you, it just helps make it happen. So I think the major thing in life is essentially believe in yourself. If you have a good idea, work it out. And if it's amazing what good ideas do work out. And I think you'd be disappointed if you had a good idea and you didn't chase it through and then somebody else did, wouldn't you? So, so for me I think it's a good idea, believe in it, and you'll find somebody else who wants to help you do it. And eventually, you and a few other people will do it, and it'll be great. And it probably will be a surprise. And I think that the best part of it is that the surprise is that sometimes it really does work, like IVF, like stem cells, and I hope like this cancer treatment, and then maybe even low-cost IVF might work for resource challenged communities. Yeah.
Yes, that's great. So you've had like so many breakthroughs, like you've given us so many breakthroughs, like IVF, frozen embryos, stem cells, then cancer now. So we wish to have more and more and more from you. So I know your family demands your time, but we are also very greedy to have some of your science coming around. That's all I have to ask to you. But there are some questions from the attendees, participants. Can I take a few for you?
Sure.
Sure. Okay. The first question is from Paresh Makwana. Which day of the embryo transferred gave you your first IVF baby, which is the third IVF baby of the world?
What was that?
Which day of the embryo? Was it a day 2 or a day 3 embryo?
It was an 8-cell embryo, so it was a day 3 embryo.
Day 3 embryo. Okay. The next question is from Varsha. Varsha is a close friend, and she did the MCE from Singapore under Dr. Bongsa. So, and she also is the first person to have had a IVF baby in India. So way back, maybe 10 years ago. And her question is, what is the scope of IVM in today's scenario, apart from its use in cancer patients for oocyte cryopreservation?
What was, again, I'm trying to understand exactly the question.
What is the scope of IVM in today's scenario, apart from oocyte cryopreservation for fertility preservation in oncology patients?
No, well, that's a very good question, because when we developed it, I actually thought, you know, we were developing it because we had patients with polycystic ovarian disease, which we were really having trouble getting, you know, getting embryos for them. And I felt that if you actually took the oocytes out of the ovary and then matured them, and then you could actually then, you know, make embryos that you could, even if you created an artificial cycle for the patient, you would be able to establish their pregnancy. So it was really about PCO that I was interested in, and that's the way I started the IVM. And I think it has been used for cancer, clearly. So you can collect the oocytes, or collect the ovarian tissue too, and keep them for the patients. But you need quite a lot of them, I guess, to ensure that you've really got a chance for a child there. I would use IVM wherever it suited. You know, if there is a condition that doesn't allow you to get embryos for some reason, but the patients have sufficient immature oocytes in their ovary, and the PCO is a classic condition where there's lots of follicles and lots of oocytes, but it's very hard to get embryos for them, then use IVM. And in my mind, it should be just part of the, you know, the tools of trade for people working in IVF. That's the way I think about it.
Okay. Then we do have other questions, and another question is, in your slide you had said that you had about 20 to 25% pregnancy rate in IVF in 1982, and after that you started cloning animals. What was the positive rate at that time?
Well, I went on sabbatical leave to learn about cloning. I went to Utrecht in Holland to work with Christine Mummery, who was doing some cloning work, and I was really interested in that from the point of view of animal research. So it was a time that I thought I could take a break from human IVF and the lab and go and learn something that was a little different. So I learned how to do cloning work there, and I brought it back to the lab, and we went on to work with the dairy industry, cloning, you know, cattle for the dairy industry. And I still have a colleague, Andrew French, who clones horses, and dogs, and cows, and all sorts of things, that works out of our lab still these days. So we still do cloning work for animals, for people who want to have that in their animals. Yeah.
I'm just going to combine a few of the questions here and put the one I wanted to ask you again, something again as well. Now we've had lots of newer technologies coming up in IVF, such as the time lapse and I think morphokinetics, and then we have the PGTA, more than what we used to do at that point of time only with fish. Now we have the NGS. So what do you think, or what is your view of all those technologies, newer technologies we have in IVF, and how do you see IVF in 10 years from now?
I think a lot of those technologies will move into automated technologies. So I think microinjection, eggs will become automated. I saw some automated prototypes from GMP Aero Palermo in New York, and I've seen the automated culture systems develop on video sort of visualization, and I think it will become more and more automated, because I just remember, in the early days when we were doing hormone assays, we used to spend days doing hormone assays, but now it's a totally automated procedure. And I think IVF will probably become more and more automated. So embryologists will become technicians involved in sort of, managing an automated system. But that's the way I think things will go. And it'll probably be better, because there'll be less errors made in an automated system. But it won't suit everybody. And so there will be people who will sort of do the old methods, and they might be, perhaps in places where you can't afford the automated procedures and so on. But I think you should use the technology wisely, and you need to prove that it's a benefit. There are many sort of party tricks in this business that don't do anything, that don't really benefit the patient, and I think you need to be sure you're not just doing it for an add-on expense rather than an add-on benefit to the patient, really. So, I mean, that's just sensible stuff, really. But I see the future will become much more automated than it currently is, and I think that will be just natural. That will happen naturally. Yeah.
Yeah, I guess so too. I guess automation is probably the future of how IVF is going to be.
Yeah.
I just wanted to, Dr. Priya Selvaraj has made a mention. She also has got one publication with your co-author, with late Professor Henry Sadanandan, from oogonia to mature oocytes. I still remember Henry with this electron microscope in our department, and he used to come and take classes, and he used to show us in his room and all those pictures he used to have. And I guess those were good times. I guess wish we could go back to student days and have those times again.
He was a marvelous man, Henry. He really was. Yeah, he was.
Yeah.
He's an absolutely delightful person, and
Yeah.
he really helped in many different things. There were many observations that he made that explains it, and so we changed things really, on Henry's advice. So he was marvelous. He was very critical for what we were doing. Everybody was, but Henry was very special. He really was. Yeah.
Yeah, he was, and he did inspire us as well to ask those critical questions at all points of time, even when we're students. So he was very special too. I guess that's all is the questions that we do have from our participants today. So I think I thoroughly, and all our participants, we thoroughly enjoyed listening to you about your experiences and how you came from 1980s to now and how IVF actually started. We have no idea of how difficult it could have been. We can't even think about it. Even when I landed in India in 2003, to set up an IVF lab took me months. Now I just have to make a phone call and it is set in like 6 weeks. My IVF lab is ready with all the latest equipments and whatever I want. It's so easy right now compared to then. And you must have had it so tough. So I guess, but when we look at the history, we get to learn more and we appreciate where we are right now. And what we have right now is the result of thinking and thoughts and hard work of scientists like you, pioneers like you, that we've had so much of technology. And my patients, they benefit every day from the freezing of embryos and the FETs and everything. So I guess you're there in our thoughts on a daily basis. Whenever we do that, we're like, oh, we know it happened. So the back of our mind, it's always there. Thank you so much for all the scientific inputs you've given us all through your life, for your dedication, and for joining us today here as well.
Thank you, Priya. Thank you to everybody. Thanks, Alex, and Shipra, and all the people, Aman, who sort of work behind the scenes. Thank you very much. I enjoyed the discussions, and thank you, Priya, for such a sort of well worked out set of questions and so nicely put. So it's been very interesting discussion, and I hope people have enjoyed it. I have.
Definitely. Yeah. All our participants have, and the president of ACE India, Swami, has also put in many comments saying that how much he enjoyed our discussion as well. All of the embryologists, all the IVF clinicians, everyone, we all really look up to you, and so we thoroughly enjoyed listening to you. And for me, it's like seeing you after such a long time. It's amazing.
Fantastic. Thank you.
Thank you. Thank you so much. Shipra,
over to you. Thank you so much. Thank you, Dr. Alan and Dr. Priya. I think it was amazing listening to you, Dr. Alan, from animals to humans to stem cells and now cancer treatment. There's no stopping you. Of course, another priority, as you mentioned, your grandchildren. And one thing which I kind of really felt, and you've strengthened my belief in, is if you believe in something, if you have an idea, go try it. It kind of works. So there's a saying that we all say, very Bollywood style saying. It says that if you believe in something and if you truly want it to happen, the entire universe conspires to make it happen.
Right.
So it's almost similar to what you said. So yes, very good learning, not just from the life in research that you've had, but also in general, how one should believe in, your ideas, thoughts, and how one can grow in life. Thank you very much, for being here, for giving us your time. And thank you, Dr. Priya, for actually sparing the time and doing this wonderful interview with Dr. Alan. Thanks a lot.
She's wonderful.
Thank you.
That's great. Yeah.
Thank you,
Thank you
Dr.
so
Alan. Thank you very much. It was a really honor for all of us, and we really enjoyed, and it was really honor. And thank you, Priya, for conducting a very nice program. And we definitely this team is recording the thing. So those who couldn't attend, I think definitely they are going to get that.
Absolutely.
So it was a nice evening. Thank you very much.
Thank
Thanks
you. And
very
thank you everyone for joining us. Thanks a lot. The recordings will also be available for you. Thank you very much. Bye-bye.
Bye.
Good evening.
Bye.
Good
Bye.
night.
Thank you so much.